so going through the skunk questions first. Technically, how would number 1 be written? All right, let's go backwards. What is number 2 asking? Probably rolling double 1, which is what?
1 on 36.
1 on 36. Technically, what is 1 asking?
What's the probability of rolling a 1 on 1? Or like for an individual roll. This is 1 roll.
So
It's asking essentially the probability of rolling that game.
which means could be that one of them is a 1 or both of them are a 1. Does that make sense? Like, why do I not need to talk about or both of them are a 1? It kind of fixes itself there. I want to write this down in pieces. Let's think about it as we're doing 2 events. First one, second one. First die, second die. So if we do it that way, then how are we writing it? So 1 on the first die and 1 on the second die is what we're going to write. Probability of what? Roll 1 on the first. What?
And 4.
As opposed to this one, which would be what?
Roll 1 on the first and roll 1.
This would be roll 1 on the first die and roll 1 on the second die. That is not what this is. So, what's the probability that we roll a 1 on the first? What is the probability that we roll a 1 on the second? But what? And what's that probability? So 6 plus 6 minus 1 actually gives me so the probability that you are standing and you lose all your points for that round is 11 out of 36. I didn't word 3 very well, but I'm hoping y'all got the point of what I mean. Doesn't matter if I just rolled snake eyes. What one word point am I trying to get there? What one word conversation do I want to have with number 3? If I just rolled snake eyes, what does that mean for my next roll?
It's probably
You don't have to roll.
It does not matter at all. Why? One word. Because they're independent. When I roll a die once and I get roll 2 dice once and I get snake eyes, my probability of the next time has nothing to do with what I just rolled, so it doesn't matter at all. So they're independent, so no, it doesn't matter if I had just rolled it before. Now, some of you are going to get confused with the way I worded it and think like, well, it doesn't matter now because I have to start with 1, and that's fine if you took that perspective. It doesn't matter now because everybody's got to start with points, so you can't like lose points if you don't have any to lose. If you took that perspective, that's fine. But the main thing I want you to see there is, so like if I had just rolled snake eyes 3 times that game, should you be like, well, let me keep going because there's no way we're going to get snake eyes? No, because every time I roll the die, it's independent. Like that's the whole point I wanted to talk about with 3. Questions with any of those? All right, so homework, bookwork. Conversation 88 seemed to be an issue. Is that right? Were there any other ones that were big issues other than 88? Okay, so I go a little bit quicker on the ones that aren't 88. Suppose that 10% of adults belong to health clubs, and 40% of these health clubs go to health club members go to the club at least twice a week. What percent of all adults go to the health club at least twice a week?
I was confused because we talked about multiplication in class yesterday, but not like general multiplication.
The general multiplication rule is that it's probability of A times probability of B versus probability of A times probability of B given A. That very last thing that we wrote from yesterday. I just didn't write it's called multiplication rule. I might skip around with these.
Can you do either 80 or 80?
I'm going to do them all.
Okay.
I'm just maybe going to go in a different order.
Okay.
Let's start with this one because it told you to draw a tree diagram. So, voters in a large city are 40% white, 40% black, 20% Hispanic. A mayoral candidate anticipates attracting 30% of the white vote, 90% of the black vote, 50% of the Hispanic vote. So it says draw a tree diagram. How many different levels should my tree diagram have? 2. What is my first level in general and context? The percentage of the population. How many options do I have here? What are my options here? What's the probability that they're white? Probability of black? Probability of Hispanic? What's my second level?
How many voted for him?
So, with this person, what are my options for this? Did or didn't? I usually write check X. Did, didn't, voted, didn't vote for. I don't care how you write it. So, this right here is a what kind of probability? Is it just a regular probability? Is it a total probability like marginal? Or is it something that's given a condition? It's a condition. So the condition was what here. So knowing that it's already white vote here, he's going to attract 30% of those. So this is 0.3. This is 0.7. What are my options off of this one for this level? Did or didn't? What's this one? 90, right? 0.9. And this one is? And then, so Hispanic, again, did or didn't, would be what? 0.5, 0.5. So that's just setting up my work. I wish I would have seen this before, not told you to do that. What percent of the overall vote does the candidate expect to get? So this is what I want to bring up a little bit more today. I want to figure out these like we did with the sums yesterday. So how many possible outcomes are there here? There's 6 different outcomes, right? So how do I figure out the probability of this path? Multiplication. So this gives me 0.12. So a rule of thumb here in a tree diagram is you mathematically do what going this way? You multiply going down. So multiply going down, 0.28 if I want to write all these out, 0.36, 0.04, 0.10, 0.10. How do I know that those look right? These two together have to be how much? These two have to be this much. These two have to be this much. These all have to be what? If it's a test, it takes 2 seconds to look at that and make sure they add up to 1 and you didn't make a mistake. So I've got all my different paths. The probability that they were white and voted for him is this, so forth. Percent of the population that was white and voted for him is this, because and is multiplying down. Now, but what it actually asks about is what? So how many of these would satisfy what we're looking for? So it could be this path, what this path, what this path. So this path or this path or this path, so we're adding those. Which gives me what? So my rule of thumb that I always say is in a tree diagram, mathematically you do what going down? Multiply. But if you're going across, you add. If you tried to Google something else online and look up tree diagrams, I don't care if you did, a lot of other people choose to make tree diagrams this way. For some reason, to me, I don't like that. Like, my brain only goes towards this, like this way. That's the way I like doing them this way better. It doesn't matter, it's going to do the same thing. But if I say my rule is to multiply down and add across, is that going to directly apply to this? No, because it's not listed, just make sure I'm not showing there. So still going back with this one. Now let's just look at this statement. And this is actually back to chapter 1. What percent of her votes, oh, was it her? Oh, was a girl, sorry. Should have said her, so him. What percent of her votes come from black voters? So, what is this? That is a condition. So what am I trying to find the probability of?
Black voters given the voting choice.
Does that make sense? And for now, I can just look at my tree diagram. What was my answer for? So I'm only dealing with out of a total of what? So when I was thinking about it like a two-way table, it would basically be like, hey, I'm just taking ones that were checks. And now what percent of those were?
0.58.
So out of 0.58, so that was our answer for the last problem. How many of the total were this? 0.36. And this is all just based off of putting things together. We're going to kind of make it a little bit clearer today with why that is that. And I'm probably going to come back and write it in just a second. That's why I'm skipping around. Let's go ahead and write this. All right, so the 0.58 is the probability of what? Everybody go with that? That's the conditional. Whatever the condition is, what goes on the bottom. What goes on top? And this book, I will tell you, I don't know if they tried to be so inclusive of people that some of the questions are borderline trying to read them. Like one of the problems is like, black old men get this more than other people. Like they word things really strange. So I'm not trying to be politically correct and politically correct. I'm just reading problems here. They do things really weird. Like we'll probably get to that problem eventually. So the way it's worded, what does it say? Where does this come from?
Black men.
Everybody go with that? Alright, so let's go ahead and think about this while we're here. You don't need to, I'm going to have you write something about this eventually, but we're just going to go add it to yesterday's note. So I am set up with, I'm going to use different letters here just to make it easier. So let's say we're going to say probability of B given A, and over here I'm left with probability of A, of B and A, over probability of B. Thank you. I'm just rewriting those as B's and A's, right? Let's rearrange this mathematically, and let's say I want to solve for and. What do I do with this? Does that look familiar? That is our equation the way we wrote it yesterday. And it is this if A and B are what? Not independent. Sometimes it's actually easier to use this equation this way, but we're doing the same thing and plugging it in. So let's open up our notes from yesterday while I'm thinking about it, so I don't want to forget. And just write this with conditional. So we've already written conditional in our notes. And I just want to add just one piece to the part where we wrote conditional. You should have room off to the side because I just wrote a definition and wrote this means given. So this equals, what do I write on top?
P and B.
Does it ever matter if I say A and B or B and A? No, because and means both of them are already. The part that's important is what goes here. One on the right, your condition. So that's probability of B. So you thought through this process in your homework, but sometimes it's easier knowing this and thinking, okay, I can go straight to that. Alright, so now I'm gonna start back at this one. Suppose that 10 adults belong to a health club. So I would not have wanted you to start where I am gonna start now that we know this. But let's write things out. What could I write as that part? We'll say B is belong. We go with that? That kind of thing, that's vague, and I would need to write something off to the side. I'll write something out about that. So probability that they belong is 0.10. We'll call T twice a week. But this says 40% of these. So how would I write a P parentheses for just that second part? What does this mean? Conditional. It's saying conditional of which ones? So it's conditional that they belong. Now, what goes here? And obviously this is not the way you should have done your homework last night because you weren't thinking this way and I didn't want you to think this way. What percent of all adults go to a health club at least twice a week? So we're trying to find probability of what?
B times probability of T and B.
We're trying to find P out of the whole population.
That one's kind of funny. Why? It's worded as I would write it as what? Probability of, kind of written as I would write it as probability of T, right? But why is it actually both? Can you go to the club twice a week if you're not a member? So you have to be a member to go. So what's our equation for this now that we know it? Now that we know that's the scenario? So this is not how you would have approached your homework, but this is doing the same thing. I'll go over it the other way too. So probability B is 0.10 times this one, which is 0.4 for a probability of within probability, there will be a lot of problems where you and the person beside of you do something completely different the way it looks, but you're actually doing the same thing. Is what I did probably like any of your homeworks? Probably not. That is fine. So now let's look at it the way you would have done it. So let's think about tree diagram to start out with. So the first thing it gave me, so how many levels is my tree diagram going to have? 2. And y'all might not have even done it this way. The first one is that I belong. Either do or I don't. What's the probability that I belong? 10%, which makes this one. What's my second level? What over here? Because if they don't join, can they come? So technically I could write it like this. But this would be what? And this would be 1. So now, and 40% of these health club members go at least twice a week. So this is 0.4. This is 0.6. So what's this problem asking for? This path. How do I do this path? 0.1 times 0.4. Is that the exact same thing that I did without the tree diagram? Yes. So you're going to start to see how, like, some people just go straight to tree diagram. Like their brain goes straight to tree diagram. And some people think, let me write things out and see what I can piece together. It doesn't matter which way you do it. One big thing here is, we said this means what? That it's a, what kind of probability? Conditional. In a tree diagram, are the conditionals going to be up here? No, because they haven't gone through a condition to get there. So these are your conditionals of a tree diagram. Just kind of making sure y'all see those connections. We saw in an earlier example that 93%, and here I told y'all I was going to go quick over homework, I'm taking forever. We saw an earlier example that 93% of teenagers are online. We can do this one. Let's just do this one as a tree diagram. So they are online, like this old textbook, or not. Which leaves this one to be. And that 55% of online teams have posted. Which leaves this. What about over here? 0 and 1 again. Of teams with a profile. So, which ones have a profile? This path, right? 75% have placed comments on a friend's blog. Oh, I have a third thing there. So then I have a third level. A friend's blog. This is 0.76. All this problem wants you to do is do what now? And you do what with those because you're going down? Multiply 0.93 times 0.55 times 0.76 for your answer. What did you end up getting, said? 0.039 or 0.39? 0.39. All right, so all I have left is 88. So this is tennis. This one always throws people off. In tennis, you get to serve once. If you need to, you can serve again if you fault. And you're trying ultimately to do what? Win the point. So my first level is my first serve. Go with that. What is the problem? So my options for my first serve are in or out. What's the probability that it's in? Which means what's the probability that I miss? Everybody good to start there. So now what's my second thing? It's actually your second serve. What is it here? Do I need it? Do I need it here? So what is my probability that my second serve is in? What's the probability that the second serve is out then? Ultimately, I want to see if I do what? If I were this path, could I win or lose? Do I have the option of winning the point or losing the point? No, I'm only going to what? Or I could write win with 0, and then I don't need it. If I get this path, could I still win or lose?
Yes.
What's this probability? Well, so if I win the point, get first serve out 6 or 0.59, which makes this one. If the first serve is in, can I win or lose? What's the probability that I win? Probability that I lose? Now, would it be a hard problem? It's just the fact that you don't need this if you go this path. So now I'm looking at paths here. I can sit here and multiply all those and get them all the answer, but what is the probability that the single serving player wins the point? So how many of those paths are win? This one and this one, right? So really, technically, those are the only ones I needed. So what's 0.59 plus 0.73? 0.43 what? What's the probability of this path? 0.41 times 0.86 times 0.59. So this path I would win, or this path I would win. So whenever we do or, we mathematically do what? Add. So I'm taking 0.4307 plus 0.2080, and I get what? For these problems, if I go to a problem like the one I was talking about with something like here, we said this part needs conditional, right? Would I want to do a two-way table with conditional? If you did, now you'd have to think about it like, what is it? These problems. So this one is they belong, or they don't. Probability they belong is 0.10. Of these, 40% are twice a week. So then I'd have to think through that and actually do 40% of this. Would that still work? Yes, but I would usually not recommend going the direction of a two-way table if it is conditional. I would go tree diagram because it makes like you have to do math within and then it gets confusing. But you still could. So different people are going to think different ways throughout these type of problems, and it doesn't really matter which one you choose. You're all going to get to the same point. Questions about anything with homework?